This lesson is going to focus mostly on particle diagrams, and we'll relate this back to concept B, which was on the classification of matter. So you should be able to begin to interpret and identify particle diagrams representing the different types of matters. You should also be able to draw or depict particle diagrams representing the different types of matter. So first off, particle diagrams. This is basically how forms of matter look in a simple diagram form. Now each type of circle or symbol is going to represent a different type of particle or atom depending on what we're looking at. So here are some examples of an element. You'll see that each sample has the same type of atom throughout. That's what makes it a substance. On the left, this is an example of what we call a monoatomic element where we have single atoms, and then here we have a diatomic element on the right where we have two of the same type of atom bonded together, and those exist throughout the sample on their own. So example of this would be something like chlorine gas, which is a diatomic element of Cl2. Alright, here's a compound, another type of substance. On the left we have one which is made up of just one lead and one oxygen atom, so lead oxide. And then we also have another form of lead oxide where we have now two oxygens and a single lead atom in the middle. So both of these are examples of compounds. Within each sample, the same type of compound is repeated throughout the sample. We don't see anything else there, or else it would be a mixture. So we have a pure substance here of a compound. Here we get into mixtures, and you'll see that within each mixture there's going to be two or more distinct types of particles. Here we have solutions, so they're going to be spread out evenly or being dispersed evenly. On the left, this is an example of two elements in a homogeneous mixture, and on the right we have an example of an element and then a compound. So the blue dots here represent the element, and then the set of three dots, two of the same and one different one, is going to be representing the compound. These are evenly dispersed. So on the left, the two I'm circling make it a mixture because I automatically have two different types of particles. And then same thing on the right, I have an element and a compound, and then they're dispersed within each other, so that makes it a mixture as well. Finally, the heterogeneous mixture, visually what you'll see is them being clumped together. On the left, we have two elements that are unevenly dispersed. And then on the right, we have an element and a compound that are unevenly dispersed. So again, as soon as you see two different types of particles in your drawings, that identifies it as a mixture, and then you need to look at how they're dispersed throughout the mixture. Alright, so here's a little summary of what we've done in concept B and C. Matter, you first want to ask, can it be separated by physical means? If it can, then it's a mixture. If it's not, then it's a substance. And then from a substance, you want to think about, can it be separated by chemical methods? If it is, then it's a compound. So compounds cannot be separated by physical means, but they can be separated by chemical. And if it's no, then it's an element. So elements cannot be separated by physical or chemical methods. On the mixture side of your paper, you want to ask then, is it uniform or does it look the same throughout? If it's a yes, then you have a homogeneous or homogeneous mixture. If it's a no, then you have a heterogeneous mixture. Alright, so if we look and just review what we've done in the last two concepts. Elements, you find these on the periodic table. They're going to be the names or symbols of single elements, and the sample should look the same throughout. A compound has two or more elements that are chemically combined, but again, throughout you have the same type of particle just repeated over and over again. Heterogeneous mixture, in class we talked a little bit about colloids and suspensions. Here they're going to be clumped together so that we would see the different types of particles within the mixture. And then a homogeneous mixture, or also called a solution, is going to be evenly dispersed. So even though we have two different types of particles, they're evenly dispersed within the sample. Alright, so that was just a quick little review, so go through these two particle diagrams. You might want to pause it for a minute, try them out, and then check your answers. So number 1 says which particle diagrams represent a pure substance. So you're looking for in the particle diagram which one has a particular type of particle and then everything matches it. So based on that, number 1, 3, and 4 are all examples of a pure substance. Within each you have the same type of particle repeating over and over again. Number 2 has a mixture of two elements. And then number 2, you should have selected 2. This asks for a mixture of one compound and one element. Here, number 1, we have a mixture of two compounds. 3, we have a mixture of elements, specifically diatomic elements. But then right in the middle, number 2, the black dots are our element, and then the blue and white are representing our compound. So number 2 should be the one that you selected. Okay, that was quick. Just a quick summary. We're going to work on these particle diagrams. It's important that you get that abstract representation. We also will be doing a lab focusing on that idea as well.